Welcome, we're doing chapter 3.1 and 3.2. Alright, these are our objectives. We're going to work with recognizing and evaluating exponential functions. This is a typo. This x is supposed to be an exponent. So what we're going to type into our calculators is 7,000 times 2 to the negative 2.5. When we type that into our calculators, we have 7,002. And we get 1237.43. Now it's 6/8. We're rounding to 3 decimals. That becomes a 7. So that would be our answer. Match the function with its graph. You can plot this in your calculator, but we can also remember from our standard equation, I apologize, that this means we shift 5 units to the right. So that's going to be this particular shift. Right here, at 5 units, you should be at 1. Okay, so this is our answer. You can plot it on a calculator and see it. Alright, use a graphing utility. So if we put this into our calculator and we go to our table function, we go to the -1, I get rounds to 0.04. I apologize. I need to erase that. 0.004. We have 0.016. It rounds up. We have 0.063. Again, rounding up. 0.25. It's only 2 digits, so it doesn't need to be rounded. And 1. All right, sketch the graph of our function. Basically, it comes right along the x-axis, gets just a little bit past, and then hits basically straight up. 1-to-1 property. This means that if I have 2 to the x is equal to 2 to the 4th, I know that x is equal to 4. If it's the same base, I can set the exponents equal. So I'm going to rewrite 1 over 8. Goodness, I apologize for that. Okay. Okay, sorry about that. It took me a few minutes to get that to erase. I don't know what happened. So what I'm going to do is turn this into 1 over 2 to the 3. I can bring this into the numerator by giving it a negative exponent. So now I have 2 to the x minus 7 equals 2 to the negative 3. So I can set my two exponents equal, and that's how I'm going to get the value of x. So I add 7 to both sides, I get x equals 4. Now, what we have to do is realize that this is our parent function. So this is a rotation and a vertical shift. So the shift is 7 units down, and we have a rotation around the x-axis. If you graph these two, you should be able to see it. F of x equals 0.9 to the x. It's going to look like this. Whereas my other equation is going to be way down here and go like this. Oops, wrong. There's 2 shifts on that one. I apologize. Won't look exactly like that. Okay, I apologize. So let's redo these graphs. Okay, so I've got an eraser. So that one's not right either. So what I'm going to do is show you what these graphs should look like. Okay, green, I'm going to do the 0.9x. And what it is that 0.9 makes it super flat. So it's going to come in and just go right along there. And then we're going to be dropping that 7 units. And not only are we dropping it 7 units, there we go, it's rotated. So instead of sloping down, it's actually now going to slope up. This is 7, or -7, I should say. Alright, so let's look at base E. Recognize and evaluate and graph exponential functions with base E. Evaluate the function at the indicated value of x. Round your results to 3 decimal places. So all we're going to do is plug that 12 in for x. So we're going to type into our calculator 250 times e to the 0.08x. Remember, e to the x is on the calculator, right, just slightly above to the left of the 4. It's second natural log. Okay, so 250 second natural log gives me e to the, now I'm up in my exponent, 0.08 parenthesis 12. Then I hit enter and I get 652.924, rounded to 3 decimal places. Alright, go do your in-class practice and then come back and I'll have the answers for you.